Welcome back. For those of you joining us for the first time, well, this is your shortcut to being well-informed.
Absolutely.
We take a stack of, highly specific sources, articles, confidential research, pitch decks, and we extract the absolute most important insights.
And we do it fast.
Right. Every deep dive is custom tailored for a single listener to make sure you get exactly what you need to know without, drowning in information overload.
Exactly.
And today, I want you to start by picturing something for a second. Imagine a multi-billion-dollar industrial mansion.
Okay, I'm picturing it.
It is this massive, state-of-the-art facility, right? The machinery is producing nonstop, and the profit margins are flowing perfectly. But if you look closely at the architecture of this empire, you notice a really terrifying detail.
Right, it's the ultimate structural flaw just hiding in plain sight.
Yes. The entire sprawling mansion, all of that heavy machinery, it gets its lifeblood from a single giant extension cord plugged into a wall hundreds of miles away.
And here is the kicker. That extension cord runs straight through the middle of an active minefield.
Exactly.
Which means if anyone trips over that cord or, if a geopolitical mine detonates half a world away, your entire industrial mansion goes dark in milliseconds.
Just completely shuts down.
Yeah, and the financial losses become incalculable before you even know what happened.
It's a brutal analogy, I know, but looking at the sources we have today, it perfectly captures the reality of modern heavy industry. Massive operations are completely dependent on this distant, highly vulnerable power grid.
They really are.
So, we are going to look at how that paradigm is fundamentally changing. Our mission today is to examine a fascinating stack of confidential venture capital pitch decks, business plans, and market analyses.
From a very interesting startup.
Right, a company called Styler Energy. We're looking specifically at their groundbreaking infrastructure project called Energetic Heart,
which serves as a literal blueprint for how the world's heaviest industries can finally cut that extension cord forever.
Okay, let's unpack this. We're going to evaluate the financial viability of Energetic Heart, specifically for an investor audience.
We'll look at the actual numbers.
Yeah, we're going to explore how they are decentralizing industrial energy, how they're solving massive power bottlenecks for things like green hydrogen and AI data centers, and turning heavy industry's biggest operational vulnerability into a highly profitable, predictable asset.
It's a huge shift.
It is. But to understand the solution, we kind of have to look at the minefield first.
Yeah.
And just to be completely clear for everyone listening, looking at this stack of research, our sources document some pretty severe military events in the Middle East.
Yes, they do.
And I want to be upfront. We are stripping away the politics completely. We take no political sides here. We're looking strictly at the mathematical and logistical impact these events have on the global energy supply chain.
And mathematically, the numbers are devastating. What the data shows is a systematic, highly effective targeting of centralized fossil fuel infrastructure. To give you an example from the reports, just look at the recent escalations targeting critical installations in Iran, specifically the South Pars gas field.
I saw that in the notes, but what is the actual scale of South Pars? How much of the grid actually relies on that one location?
It is immense. South Pars produces between 70 and 75% of Iran's entire natural gas supply.
Wait, 70% from one field?
Yeah, just that one location. And that directly feeds 80% of their electrical grid.
Oh, wow.
So if you disrupt it, you don't just cause a localized blackout, you essentially paralyze the energetic heart of a nation.
That's terrifying.
But for the global market, the panic really set in with the retaliatory strikes detailed in the documents. We're talking about the destruction of Qatar's Pearl GTL.
Now, that's a liquefied natural gas plant, right?
It is. It's actually the world's largest liquefied natural gas plant.
Which perfectly illustrates that extension cord in a minefield concept we talked about. The whole centralized global grid basically assumes you can safely extract massive amounts of fuel in highly volatile regions, process it in these giant hubs, and then ship it across the oceans.
Exactly. And when a facility like Pearl GTL goes offline, you destroy the capacity to compress and export that energy.
And the market reacts immediately.
Oh, the global market reaction to that kind of bottleneck is instantaneous. The moment that export capacity was threatened, the price of a barrel of oil spiked past $111 immediately.
Right. So imagine you are the CFO of a massive copper mine in Latin America.
Okay, tracking.
You rely on your local centralized grid, which of course relies on the global market for fossil fuels. Suddenly, your operational costs skyrocket overnight, and you haven't done a single thing wrong.
Nothing at all?
Your operation is just paralyzed by external volatility. Which leads me to a really basic question. If relying on this distant grid is this mathematically risky, why hasn't heavy industry unplugged earlier?
It's a great question.
Like, why wait for a massive geopolitical crisis to seek autonomy?
Well, that comes down to a critical engineering concept called firmness, or in the Latin American markets they're targeting, it's called energia firm.
Firm energy.
Right. A major mine or a metallurgical plant, they can't just flip a switch and pause operations when the wind stops blowing or a cloud covers the sun.
They need it constantly.
Exactly. They require 24/7 unwavering baseline power.
Because a blackout in a mine doesn't just mean, the office computers reboot.
Far from it. If power drops at a metallurgical plant, the giant smelting furnaces literally begin to cool.
Oh, I didn't even think about that.
Yeah, the molten metal solidifies inside the machinery. You are talking about millions of dollars lost per hour of downtime, plus the cost of literally jackhammering ruined equipment to fix it.
That is a nightmare scenario.
Historically, the absolute only way to guarantee that massive continuous volume of power was by hooking up to a massive grid powered by centralized fossil fuels. Industry just accepted the geopolitical risk because it was the only technical way to keep the furnaces running.
Right, until the technology caught up.
Yeah.
Because if industries absolutely must have 24/7 firm power, and the centralized grid is now this massive financial liability, the only option is to generate that firm power safely, right there on the property.
Exactly.
And that is the exact innovation Energetic Heart is pitching. They call their solution portable rivers.
Which is such a cool name. What's fascinating here is how they have essentially packaged the raw force of nature into a deployable industrial product.
I was reading their technical breakdown, and it is a wild concept. A portable river is this closed-loop, modular micro-hydroelectric generation system.
Right.
You install it right in the industrial customer's backyard. It doesn't need to be connected to a natural river at all. The deck says it uses a confined volume of water, driven by gravity and high-efficiency pumping, to create an endless artificial waterfall.
It's brilliant.
And once you fill it up, it requires zero extra water consumption.
Which is an incredible operational advantage in arid mining regions, right? Where water is scarce.
It is, but I have to stop and push back here for a second.
Go for it.
Because I'm looking at this diagram, and my high school physics alarm is ringing loudly right now.
The perpetual motion thing.
Exactly. If you pump water up a tower, it takes energy. When it falls, it generates energy. But you always lose some energy in that mechanical transaction. It sounds like they are pitching a perpetual motion machine, which is physically impossible.
Yeah.
How is this actually generating power?
That is exactly the right question to ask, and no, they haven't broken the laws of thermodynamics.
Okay, good.
Think of this system not as creating energy out of absolutely nothing, but as the ultimate mechanical battery and kinetic converter. What they are doing is decoupling the generation of energy from the consumption of energy.
Okay, walk me through that. How does that work?
So a remote site can use highly intermittent, extremely cheap local energy, like an off-grid solar array, to power the high-efficiency pumps during the day.
Oh, that makes sense.
But obviously, solar disappears at night. By using that solar power to push the confined water up during the day, that water becomes stored kinetic energy.
Ah, I see.
Then the gravity-driven downward flow releases that energy as a massive continuous force whenever they need it. The killer thermodynamic metric here, and the one investors really care about, is the capacity factor. Energetic Heart operates at over an 80% capacity factor.
Wow, which is an absolute game changer, because if you look at standard solar and wind, they are fantastic, but they suffer from structural intermittency.
Very much so.
They usually offer, less than a 30% capacity factor?
No. Exactly. So to run a 24/7 mine purely on solar, you would need massively expensive, city-sized lithium battery banks just to cover the gaps when the sun goes down. It's totally cost-prohibitive.
Right. And the other alternative, like diesel generators, they might be reliable, but they are incredibly expensive to fuel and highly polluting.
Yeah, a logistical nightmare.
So Energetic Heart is taking that intermittent energy and smoothing it out to offer 24/7 firm, zero-emission baseline power. It makes me think about the evolution of computers, actually.
How so?
Well, the traditional centralized power grid is like an old, massive mainframe computer from the 1970s. It's clunky, it's centralized in one building, and if the mainframe crashes, every terminal goes dead.
Oh, that's a great analogy.
Energetic Heart is basically introducing the cloud computing of heavy energy. It is nimble, it's decentralized, and is available exactly where you need it, right behind the meter.
If we connect this to the bigger picture, this kind of continuous, decentralized power isn't just a survival mechanism for traditional mining. It happens to be the exact missing key for the two most energy-hungry technologies of our future:
Which are?
green hydrogen and artificial intelligence.
I'm so glad you brought that up because the market potential in the pitch deck just explodes when they start talking about hydrogen. Let's look at green hydrogen, or H2V, first.
Yeah, think of green hydrogen as a chemical vault for storing energy. It is brilliant for the energy transition.
All right.
But the bottleneck right now is the production side. To make green hydrogen, you use machines called electrolyzers to split water into hydrogen and oxygen.
Right, I've heard of that.
But for those electrolyzers to be financially profitable, they require a continuous, massive supply of cheap, green baseline power.
So if you run an electrolyzer on intermittent solar, it just turns off every time a cloud passes.
Yep.
And the economics fall apart entirely.
Precisely. And that is why Energetic Heart is positioning itself as the crucial first link in the green hydrogen value chain.
It's total sense.
By providing that 80% capacity factor, they enable the decentralized on-site generation of green hydrogen. They're essentially creating the technical maturity the entire H2V ecosystem needs to scale.
And then you pivot to AI data centers. We all know AI is booming, and the compute demands are staggering. I read recently that a single ChatGPT query uses nearly 10 times the electricity of a standard Google search.
10 times. It's wild.
Now multiply that by billions of queries a day. AI models do not sleep. These compute clusters operate at 100% capacity, 24 hours a day, 7 days a week.
Right.
The public grid simply cannot supply enough clean baseline power to support them.
Data centers are facing an existential crisis right now because of this. They have strict zero-carbon sustainability goals, but the grids are so congested that tech giants are literally considering firing up decommissioned coal and gas plants just to keep the servers from crashing.
Which completely destroys their green mandates.
Ex-
So Energetic Heart steps in as the operational survival tool these AI centers need. You install a portable river next to the data center, and you get continuous, clean power without relying on the public grid at all.
It matures the ecosystem across the board. Whether you are talking about mining in the Andes, hydrogen production, or AI server farms, they all share a foundational vulnerability.
The need for clean, decentralized baseload power.
Exactly. And Energetic Heart solves it.
Okay, so the thermodynamics make sense now. The engineering is fascinating. But as an investor, looking at these pitch decks, I have to play devil's advocate for a second.
Sure, let's hear it.
How does this actually make money? Building heavy physical infrastructure. I mean, you're essentially building micro dams. That has a massive upfront cost. The CapEx must be staggering.
It's a lot of metal and concrete.
Right. So how are they convincing a mine or a data center to drop millions of dollars on unproven hardware? How do they not bleed out in year one?
This raises an important question, and it is where the financial engineering of Styler Energy is just as innovative as their mechanical engineering. To answer your question, they don't convince the client to drop millions on hardware.
They don't.
No. They use an energy as a service model, or EASE.
Wait, are you saying the industrial client pays zero upfront capital expenditure?
Zero CapEx.
So nothing.
Nothing up front. Styler Energy retains ownership of the physical infrastructure. They don't sell the machines, they sell the energy the machine produces.
Okay, wow.
And the revenue formula is brilliant because it is based entirely on guaranteed savings. Energetic Heart charges a fixed tariff based on the energy the client consumes. But they set that tariff to mathematically guarantee the client a 40 to 50% reduction compared to what they are currently paying the volatile public grid.
Oh, wow. That is a phenomenal pitch to a CFO.
Right.
You walk into a massive industrial facility and say, hey, we will install this infrastructure for free, guarantee your power 24/7 so your furnaces never solidify, and instantly cut your energy bill in half.
It's a no-brainer.
It turns the client's volatile operating expense into the startup's value-generating asset. But, I mean, how do the unit economics work for the startup over time?
Well, they secure these deals through power purchase agreements, or PPAs. Because the client is relying entirely on this infrastructure for their baseload power, they lock in 15 to 20-year contracts.
2 decades of guaranteed revenue.
Yes. And consider the churn rate. In traditional software, a SaaS company worries about a 5 or 10% annual churn where clients cancel their subscriptions.
Sure.
In this ESS model, an industrial mine cannot simply unplug from its baseload power without halting its entire multi-million-dollar operation. So the churn rate is effectively 0%.
It's like the Hotel California of energy contracts. You can plug in anytime you like, but you can never leave.
Exactly.
So what do the margins look like on a 20-year lock-in?
The gross margin is projected at a staggering 80 to 85%. Why? Because once the physical system is built and paid off, the raw material, the confined volume of water utilizing gravity, is completely free.
That allows them to project a payback period to recover the entire cost of the physical asset in under 48 months, right?
Yes.
So after year 4, it is pure net margin for the next decade and a half. They're essentially transforming heavy hardware into a high-yield, fixed income bond for their investors.
That's exactly how the VC world sees it. But of course, a great spreadsheet doesn't build a real-world power plant in the mountains.
Right.
Investors want to know who is executing this and what the current traction actually looks like.
Okay, let's look at their current cap table then. The deck outlines a $1.5 million seed round, and they are raising that at an $8.5 to $10 million post-money valuation.
Yep.
But what really caught my eye is the institutional momentum.
It's very significant. A fund called Carbon03 is acting as the lead investor. They are currently in advanced due diligence and have $500,000 already committed to the round.
That kind of institutional backing is a massive signal to other investors. But do they actually have buyers lined up? Or are they raising this money just to go hunt for their first client?
Oh, their commercial pipeline is what proves they have found serious product market fit. They have a $796 million commercial pipeline.
That is almost $1 billion.
Right. That represents 39 potential clients identified and in negotiations right now. This includes signed NDAs with major mining heavyweights like Buenaventura and Nexa Resources.
That's massive. But infrastructure is usually such an old-school, slow-moving boys club,
Sure.
Does this team actually have the agility to pull off a modern rollout, especially deploying hard tech into harsh environments like the Andes Mountains?
Actually, the makeup of this leadership team is a statistical anomaly in the heavy infrastructure space. Yeah. In a sector that is traditionally hypermasculine, 66% of their C-suite is female. You have Purina Tiravanti as Chief Digital Officer driving the modular architecture, and Jacqueline Struck as Chief Operating Officer handling the really complex logistics.
That's awesome. And I see CEO Eduardo Tiravanti brings 35 years of hardcore technical experience to the table, too.
Exactly.
That combination provides extreme operational agility. They have the deep roots to understand the harsh realities of mining, paired with the agile management required to scale a startup.
But what about the physical technology itself? Is it still just a drawing on a whiteboard?
No, not at all. They have fundamentally de-risked the technology. The system is validated at TRL6 by ProInnovate Peru.
Okay, and for those not deep in engineering jargon, TRL6 means Technology Readiness Level 6, which basically means it has moved well past the theoretical prototype phase and has been physically demonstrated in a relevant environment.
Exactly. But crucially, they aren't trying to manufacture every complex turbine and bolt themselves. They have secured a strategic alliance with Ausberger. Okay, who are they?
Ausberger is a German engineering giant with over 12,500 hydroelectric installations globally across 100 countries.
Wow.
Yeah. By partnering with them for the core mechanical components, Styler Energy ensures world-class reliability. It tells investors, hey, the physics and the hardware are guaranteed by a century of German engineering.
But here's where it gets really interesting. Because while they are building physical machines, their ultimate vision is much larger.
The softer side.
Yes, the breakdown of how they are using these seed funds is brilliant. 60% goes straight to building the first 1 megawatt physical pilot plant, which makes sense. You have to prove the metal and the concrete work.
You do.
But they're dedicating 10% of the raise strictly to R&D for what they call a digital twin.
This is the software secret that unlocks massive valuation multiples for them down the line. The digital twin is a software layer that uses artificial intelligence for predictive maintenance and remote monitoring.
Wait, explain that a bit more. So instead of just dropping a physical turbine off at a mine and walking away, what are they actually doing?
They are building the capability to monitor vast fleets of these portable rivers from a centralized cloud dashboard.
Wow.
The AI tracks the water flow, the turbine vibration, the energy output, and it predicts maintenance needs before a failure ever occurs.
I see the angle now. It transforms them from a metal infrastructure company into a cloud-monitored, software-defined asset.
Exactly.
They are merging the predictability of hardware with the infinite scalability of software. That is how you pave the way for unicorn-level, billion-dollar valuations in the climate tech space. You aren't just trusting a machine. You are subscribing to an intelligent, self-monitoring energy network.
It is really the ultimate evolution of the energy-as-a-service model.
So what does this all mean for you listening right now? Whether you are evaluating climate tech investments, trying to solve the massive energy crisis for AI data centers, or just figuring out how heavy industry survives the volatility of the next decade, the writing is on the wall.
It is.
The future of industrial power is clearly decentralized. Energetic Heart has combined the raw physics of thermodynamics with brilliant financial engineering. They have taken the biggest operational vulnerability of modern industry.
The reliance on an unstable, distant power source.
Right, and they've turned it into a highly profitable, sustainable, and reliable asset.
And if we step back, this raises a massive geopolitical question to leave you with today.
What's that?
Think about the implications if this technology scales as projected. If the world's largest mining corporations, metallurgical plants, and AI data centers successfully deploy these portable rivers,
Okay.
if they completely disconnect from the centralized grid and become entirely self-sufficient, what happens to the global balance of power?
Wow. That is a staggering thought. I mean, for a century, geopolitical supremacy has belonged to the nations that control the oil and gas beneath the sand and the pipelines that deliver it.
But if the world's most critical industries no longer need that fuel to operate their baseload power, we are entering an era where power fundamentally shifts. Geopolitical supremacy might no longer belong to those who control the fossil fuels, but to those who master the technology to be entirely independent from them. You no longer need to control the minefield if you can generate your own power right inside the mansion. It could rewrite the global chessboard forever.